Hi, my name is Morgan, and today I will be critically analyzing the standard model of the creation of the universe. The origin of our universe has been on the minds of thousands of people for many, many years. While some turn to religious texts like the Bible or Quran to find the answer, others turn to the field of astronomy. Today, astronomers use mathematical models, such as Albert Einstein's theory of relativity, the laws of physics, the laws of thermodynamics, etc., to try and determine the origin of the universe. Unlike other scientific theories, there is no universal agreement on the origin of the universe. For many astronomers, a common theory for the creation of the universe would be the Big Bang theory. The idea that the entire universe had begun from a single primordial event has been in circulation since the 1920s. This idea gained more traction when the movement of galaxies were observed by Edwin Hubble and the cosmic microwave background radiation was observed by Orno Penzias and Robert Wilson. To critically analyze this theory, we must first know its basics. The easiest way to break down this theory is to split it into stages. These stages are divided up into a sort of timeline that tells the story of our universe from its infancy to the present day. Note that even though there is a theoretical timeline in place, we currently have no way of knowing exactly when or if there is ever a point zero in the lifetime of the universe. The beginning, as we theorize, starts nearly 14 billion years ago. The universe at this point is in a hot, dense state. It's also extremely small. The ideas of size vary from that of a golf ball to the size of a single atom. At around 10 to the negative 43rd seconds, the universe begins to expand rapidly. We believe this inflation could have been started by a strong force, but the actual cause has yet to be proven. From there, at around 10 to the negative 35 seconds, the universe consists of elementary particles like quarks and electrons. The universe is superheated to around 10 to the 27th degrees Celsius. At 10 to the negative 10 seconds, the particles begin to rapidly cool and clump into particles known as neutrons and protons. At 0.001 seconds, the universe is at just the right temperature for protons and neutrons to start bonding together. They go on to form basic hydrogen and helium nuclei. At 3 minutes, it is too cool for more nuclear fusion, but still too hot to form atoms. The universe at this point is made up of 75% hydrogen and 25% helium nuclei. For 300,000 years, the universe continues to cool. Atoms form from the joining of neutrons, protons, and electrons. The helium and hydrogen nuclei go on to form hydrogen and helium atoms. Photons are also able to finally shine light. At 1 billion years, helium and hydrogen gas begin to clump together to form the first stars and galaxies. Eventually, our galaxy, the Milky Way, and our own planet came into being. Presently, we are observing our universe as it was millions of years ago because of the speeds of light hitting our planet. We are also able to observe that our universe is still expanding, and it's doing so at an accelerated rate. The Big Bang theory and its continued expansion is supported by a few pieces of key evidence. First is cosmic microwave background radiation. CMB is thought to be leftover radiation from the original expansion of the Big Bang. It can be found throughout the entire universe and varies by a very small degree. Second is the discovery of redshift. Redshift is the indicator of stars and galaxies moving in space. Hubble found through redshift that the galaxies and clusters all around Earth were moving away from us. This meant that the universe was expanding and its density decreasing. Not only that, but through more observation we have discovered that the rate of expansion is increasing. Because of this observation, scientists have coined the ideas of dark energy and dark matter as an explanation. While we don't really understand what these things/forces are, we understand what they're not. They best account for the accelerated expansion of the universe. Of course, there is more than one theory for how the universe was created. Some alternative theories include the steady-state theory and the multiverse theory. For this video, I will focus on the quasi-steady-state theory. The quasi-steady-state theory was proposed by Fred Hoyle, Geoffrey Burbidge, and Jayant Narlikar in 1993. In this theory, the universe is constantly expanding and contracting in cycles due to an unknown repulsive fifth force. While the Big Bang focuses on the universe starting from a single point in time, although we don't know when that was or even if there was an absolute zero for a starting point, the quasi-steady-state theory suggested that the universe had no beginning or end in time. The entire cycle of expansion and contraction was infinite. During the cycle proposed in this theory, matter is continuously created as the universe expands and continuously destroyed as the universe contracts. One may ask where all this new matter comes from. Hoyle stated that the matter created to keep the universe at a constant density came from black holes and quasi-stellar objects. The theory also states that elements like helium, lithium, beryllium, and boron are created from stars. Some of the evidence used to support the quasi-steady-state theory seems quite contradictory with the observations we are able to make now. CMB, for instance, is very smooth. However, the creation of matter from random black holes and QSOs would surely cause more fluctuations in the image. On top of that, the entire theory violates the first law of thermodynamics. This law states that matter cannot be created or destroyed. However, the steady-state theory is constantly creating and destroying matter. While each of these theories are valid, the one that best makes sense over the other, in my opinion, would have to be the Big Bang. While we can't understand what initially caused the expansion of the Big Bang, there is evidence in what we can observe in CMB images and redshift to suggest that it happened. The steady-state theory is also hard to comprehend in terms of its infiniteness. There is nothing that we know of that is infinite. This state of infiniteness, or having no clear beginning and no end, also conflicts with many religious philosophies in which there is a clear point of creation, thus making it less appealing to the masses. The Big Bang is also much easier to comprehend in terms of time. While the measuring of time is a construct, we understand through our lives here on Earth that things typically have a set beginning and a set end. For example, I was born in 1998. Someday I will die. My life is not forever. Inorganic objects like rocks also have a sort of beginning from magma. The same goes for objects in space. Stars are born, and once they use up all their fuel, they die. While we don't know if or when the universe will end, we expect it to have some sort of start. I also believe that the Big Bang is most commonly accepted because it is intermingled with religion. Christianity states that God created the universe, and many churches have now started to combine the Big Bang with let there be light. While each theory has its own merits, there is simply too much evidence disproving the quasi-steady-state theory, in my opinion, for it to be true. The Big Bang has much more and much stronger evidence to back up its ideas. Even with the few holes it has and the unknowns we may never be able to answer, I believe that the stronger theory of the two is that of the Big Bang.